For years, SpaceX has chased one of the most ambitious goals in aerospace history, bringing an orbital-class Starship back to Earth for a safe landing and rapid reuse. That moment may finally be approaching faster than many expected, but before Starship can touch down on the launch pad again, it must first survive one of the harshest environments any spacecraft will ever face: atmospheric re-entry from orbit. Most people have become familiar with Starship's distinctive black hexagonal heat shield tiles covering one side of the vehicle. These tiles are designed to absorb and resist the incredible temperatures generated during descent back through Earth's atmosphere. Now, however, something new has appeared inside SpaceX's Star Factory production facility. Photographs taken during early July show what appears to be an entirely new type of thermal protection tile installed near the very tip of a Starship nose cone. Unlike the traditional black design, these tiles are bright white. At first glance, it may seem like nothing more than a cosmetic change. But if history has taught us anything about SpaceX engineering decisions, small visual differences often hide major technological advances underneath. Could these new tiles represent the next evolution of Starship's thermal protection system? And could they play a critical role in enabling the vehicle's first successful orbital landing and recovery? The timing certainly makes sense. Starship is rapidly moving beyond short test hops and suborbital missions. Future flights will spend longer periods in space, travel farther from Earth, and eventually support missions to the Moon and Mars. The farther Starship travels, the more challenging the trip home becomes. During orbital re-entry, temperatures around parts of the vehicle can approach nearly 1,500 degrees Celsius. Without effective thermal protection, the stainless steel structure beneath would not survive for long. That's why the heat shield remains one of the most important technologies in the entire Starship program. With more than 18,000 individual tiles protecting the vehicle, the system must not only survive re-entry, but also allow Starship to fly again quickly. Unlike previous spacecraft that required months of inspections and repairs between missions, SpaceX wants a much simpler process: land, check the vehicle, refill the tanks, and launch again. Every improvement to the heat shield moves that vision one step closer to reality. So what makes these new white tiles interesting? The first noticeable difference appears to be their size. They seem slightly smaller than the current black tiles used across most of Starship's surface. Smaller tiles could create tighter spacing between neighboring pieces, reducing pathways for superheated plasma to penetrate beneath the protective layer during re-entry. More uniform thermal distribution across the surface could also improve overall performance in extreme conditions. The second observation may be even more important. Current Starship tiles sit above several layers of additional protection designed to act as a backup if individual tiles fail or become damaged. The new white versions may rely less heavily on these underlying layers. If true, this could suggest that the tiles themselves offer greater thermal resistance or improved structural strength compared to earlier generations. A stronger and more capable tile system would reduce complexity, lower overall mass, and potentially shorten refurbishment times between flights. Those are exactly the kinds of improvements SpaceX continuously pursues. Location is another clue. The new tiles are being installed at the very front of the nose cone, one of the hottest areas encountered during atmospheric entry. This region also contains the forward header tank, making thermal protection especially important. For now, it remains unclear whether these white tiles will remain limited to the nose section or eventually expand to larger areas of the vehicle. SpaceX may simply be focusing its newest technology on the most demanding environments first before introducing it elsewhere. Engineers often describe this approach as concentrating protection where heating loads are highest. Another change may involve how the tiles are attached. Earlier Starship designs relied on a combination of adhesive materials and mechanical fastening systems. The newest configuration appears to favor mechanical attachment methods more heavily, especially around the nose area. Repeated heating and cooling cycles place enormous stress on thermal protection systems, and mechanical solutions may prove more durable over many flights. Reducing tile loss remains one of the biggest challenges facing Starship reusability. Over the years, SpaceX has learned this lesson repeatedly. Early test flights experienced cracked tiles, detached sections, and damaged thermal protection caused by vibration, thermal expansion, and aerodynamic forces. In response, engineers redesigned mounting hardware, improved manufacturing methods, and refined installation procedures. Material science evolved as well. Some earlier ceramic formulations proved too fragile under flight conditions, forcing the company to experiment with stronger and tougher alternatives. Additional safety layers were added beneath vulnerable areas to provide backup protection whenever surface tiles were lost or damaged. SpaceX also explored entirely different solutions. One possibility involved actively cooling parts of the vehicle using cryogenic propellants. Another involved metallic heat shields that could potentially offer greater durability and easier maintenance. While promising in theory, testing revealed new complications. Extreme temperatures cause oxidation and discoloration in metallic components, making refurbishment more difficult than expected. As a result, ceramic systems continued to receive the majority of development attention. One particularly clever innovation involved filling small spaces between tiles with insulating materials designed to block hot plasma from reaching deeper layers of the vehicle. Even tiny gaps can become major problems during re-entry, making these improvements surprisingly important. Across more than a dozen Starship test flights, a clear pattern has emerged. SpaceX tests aggressively, studies the results, improves the design, and repeats the process. The appearance of white heat shield tiles fits perfectly into that philosophy. Rather than representing a finished product, they likely represent another step in a much longer evolution. Future versions of Starship may use entirely different materials, specialized tile arrangements, or mission-specific thermal protection systems optimized for unique environments. The implications could eventually extend beyond Earth return missions. Today's lunar Starship variants do not require full atmospheric heat shields because they are not designed to re-enter Earth's atmosphere. But long-term ambitions are much larger. A future transportation network connecting the Moon, Mars, orbital stations, and planetary surfaces would place enormous value on reusable spacecraft operating throughout the solar system. Those vehicles may eventually require advanced thermal protection systems of their own. If that future arrives, these early experiments could prove to be some of the first building blocks. Of course, many years of testing remain ahead. The final solution may look completely different from what we're seeing today, but every major breakthrough in aerospace starts with small experiments and incremental improvements. And right now, SpaceX appears to be writing the next chapter in Starship's journey toward full reusability. If the company succeeds, the result won't simply be another spacecraft. It will be the beginning of a transportation system capable of operating routinely between worlds. And somewhere near the tip of a Starship nose cone, a few unusual white tiles may help make that future possible.